A relationship R is called equivalence relation if these three are true. And then when we said a relation is equivalence, we write this instead of R. It's like almost the same. So this is like approximately the same, right? So we now write this means it's an equivalent. Equivalence, not equal. It means almost the same in some sense. In what sense? In terms of the relationship. So here's a first shocking fact. These are all different numbers, but we treat them the same. So they are equivalence relationship. What does it mean? 1/3 is 1/3. 2 divided by 6. Don't tell me this is 1/3. This is 1/3 after you compute the simplification of 2 divided by 6 give you 1/3. Before you do that, it's not 1/3. Can you tell 1 is 2, 3, 6? No. You said they are the same only if you simplify the expression, then you know they are the same. Similarly, 3 divided by 9 is not 1/3. You cannot say 1 is 3 and 3 is 9, right? You are saying 1 divided by 3 and 3 divided by 9 are the same. You are not saying each of the number inside the same. So this kind of thing tells you what? We can create a bunch of numbers seemingly different as the same number. Or in other words, nobody have ever said that if you see a number, it can have infinite number of other number telling you the same thing. And this is a set because you have more than one number, you have a bunch of numbers. And this whole set, we treat them as one number. This is the meaning of equivalence class. Here's another example. In clock, 1 o'clock is the same as 13 o'clock. It's also the same as 25 o'clock. We treat them the same. But can you say they are the same? No, because 1 o'clock is midnight, 13 o'clock is afternoon. Physically, it's not the same, right? For probably you sleep in 1 o'clock and you wake up in 13 o'clock. Some people have to work overnight, so that's why they have 25 o'clock, okay? So same, 2 o'clock, 14 o'clock, 26 o'clock. Can you say 1 is 13? No, 1 and 13 are different numbers. But on the relationship, we said they are the same because under the clock, we treat them equivalently. So that means what? You see there's a dot 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 here. The dot 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 here means I have infinite number of number. Infinite. This set is infinite. But you think of it. Now we talk about something infinite. But I also consider this infinite as one thing. Isn't this funny? I have a set. Inside this set, I have infinite stuff. But I now consider this is one thing. Now here's the crazy thing. This is another thing. This is another thing. You can say the thing for the 4, for the 5, and you can keep going on, right? So this is what? You have infinite number of square bracket, and each square bracket is infinite number of stuff. So now you have a second order infinite. You have an infinite number of things, which each thing is infinite. Later on, we will touch this, don't worry. So when we are talking about number, we are not talking about one thing. We are talking about infinite number of things. Okay, and we write square bracket to mean this. A square bracket means anything else such that this is true. This is an example. Square bracket 1, I will have 1, 13, 25, and then plus 12, plus 12, plus 12. So it's a set of what? Infinitely many numbers. Here is now example. Suppose now my relationship is not clock, it's just absolute value equal each other. Okay? Then what's the other equivalent class? Because I take absolute value, that means in this example, plus or minus doesn't matter. So this is my first equivalent class. That means what? 0. Because 0 and negative 0 are both 0. What is this? 1 minus 1. 2 minus 2 are same thing. So that means if I have this R, I only have 0, 1, 2, 3, and so on. And this is the clock I just told you. The mathematical notation of writing the clock is called modulo. We write x equal y cat mod 12. 12 divided by 12 have no remainder. 24 is divisible by 12, so no remainder. So they all have the same remainder, so they belong to the same thing. 1 divided by 12, integer, remainder is 1. 13 is not divisible, so remainder is 1. So they all have remainder 1. These all have remainder 11. So we have what? We have 12 sets. Each set have infinitely many number, and we count them the same. Okay, and now these three, just extra, you read it by yourself, not going to appear in exam. Oh my gosh, so complicated. Picture